When you use the current model to rank bulbs, it is often very useful to be the river, to watch the current leave one side of the battery and just watch it as it goes around to the other side of the battery. And it doesn't matter which way you go, from positive to negative or negative to positive. And every time you get to a branching point, ask yourself, does the river branch 50-50 here or some other way? If I were ranking these bulbs, I would rank A as the brightest and B equal to C as the dimmest. Why? Because all the current that goes through the battery goes through A, and then that river comes here and sees two branches that look the same, that are identical. And so the current has no reason to choose one over the other. It splits 50-50. Okay? Now, what about these two circuits? How would you compare bulb A in brightness to bulb F in brightness?
Equal.
They're the same. Remember we found we could turn the battery upside down and it didn't change anything? We don't know which way the current actually flows. There's one experiment that suggests that electrons are flowing from the negative terminal to the positive terminal. We don't do that experiment, so we'll never find out. We pretend that it's positive charge going the other way, from positive terminal to the negative terminal. It gets rid of all sorts of minus signs. So in that case, A is equal to F, B, C, D, and E are all the same. Now, this is critical. Which is brighter, C or D? Explain to your neighbor, which is brightest, C or D?
So you're not in this class, you just heard?
Yeah. That's why I need to sit in the front row.
Okay.
Yeah, further right in the middle where you can see everything.
Yeah.
If we look at the river, all of the current goes through A. It's the brightest bulb. And then when the current gets here, it sees two paths. They split and come back together here. This path is hard. This path is easy. We find the current favors the path of least resistance. I'm going to have more than half go the easy way, less than half go the hard way. Okay?
How does it, so yeah, so does it kind of like, you can peek around the corner and see?
It can. Yeah. Now, one second. I tried not to use the word voltage, but it hinges on this idea of voltage. If I take two straws, one fat and one skinny, and I blow through them, I'm putting the same push on both. But the fat one gets a huge flow through it, and the small one gets a little trickle through it. How does it know? Well, you push the same on both. One's just harder to get through. Here, voltage from here to here is the same as voltage from there to there. The push, you can think of voltage as a pressure difference. I'm pushing charge the same amount on both. One's hard to get through, so the result is a trickle. One's easy to get through, so the result is a gusher.
So if C was a break in the line.
If there was a break here, then nothing would go that way, and all of it would go the other way.
B would not light up at all.
B would be dark. Because it knows I can't go that way. Okay? Now, because there's more resistance in that left branch, it will get less current. Now, the ranking would be A is the brightest, D is second brightest, and B is equal to C. Can you justify this in one word or less? B is equal to C? One word or less? Series. Series, that's the word. Okay. Now if I look at that circuit there, and I B the river, I can rank these bulbs. Well, let me let you do it first. Which is the brightest bulb? Which is the second brightest bulb? B the river. Okay.
So it'd be E and then A, B, and C, D.
So like we're going to put them out to the split. I'm not taking it as what it is, that next split. That's going to be equal. C and D each get a quarter, and E's going to get a half, which is the same.
Which is the brightest bulb? Shout it out. E. Good. Okay. All the current goes through the battery. And then it comes up here and it has to choose between the path through A and the path through B. Does it split 50-50 or some other way? 50-50. The two paths look identical. The whole river comes back together, exactly the same amount of current that went through the battery. What goes around comes around. And then it chooses again. Does it split 50-50 or some other way? Some other way. More than half goes through E, less than half goes through the path with C and D. And then it all comes back together and goes around. So the ranking would be E is the brightest, A and B are tied for second, C and D are tied for last. Okay? And that's the way you would solve that on an exam. You would say E gets greater than half of the current through the battery, A and B each get half, C and D each get less than half.